Okay, we got to stop the bleeding. Why? Clotting itself is not a homeostatically regulated process. Blood pressure is a homeostatically regulated process, and really the techniques to maintain blood pressure, the techniques to prevent blood loss affect homeostasis through blood pressure. But this whole process that I'm going to talk about really isn't, it's not a homeostatic process. There are three things that happen when you have damage to your blood vessel. And you have to think about it like in order for you to bleed and need a clot, you have to break a blood vessel, like break it, and now you have damage to the blood vessel in such a way that a hole has been created and tissue is exposed that shouldn't be exposed. So it's the broken blood vessel that is the stimulus for everything we're going to talk about. And so let's clarify that. Your stimulus is a broken, that says R-O-K-E-N, broken vessel. That broken vessel, the cells are sad, like they're ripped apart into pieces, and now they're sad cells, and they're going to produce like, oh, dude, I just got busted into pieces, chemicals to communicate that I think there might be a problem here. Those chemicals and the exposure of collagen, right? That makes sense, that if you have an exposure of a fiber found in connective tissues, that shouldn't be exposed to the blood. You shouldn't have blood hanging out with your connective tissue extracellular matrix. And so, yeah, let's totally, like, stop this. We have to stop the bleeding. You got three things that you're going to do. Number one, and this one actually does happen first, vasoconstriction. This makes sense, right? Dude, you break a blood vessel, let's cut off flow to that vessel. Let's vasoconstrict and reduce the amount of blood that we can actually lose through the damaged vessel. Vasoconstriction is fast. It's automatic. One of the things that is, there's a chemical called thromboxane A2. Thromboxane A2. It's produced in response to broken blood vessels, and it causes vasoconstriction. There's a bunch of other chemicals that are produced. This is crazy. You are getting the Cliff Notes version of hemostasis. And you have to, I'm numbering these things, and I really wish I wasn't numbering them because you have to realize this is all happening simultaneously. So erase your numbers. Second thing that I'm going to talk about that happens simultaneously to everything else is we're going to have the formation of a platelet plug. Platelet plug. This is not a clot. It's a plug of platelets. And this broken blood vessel stimulates the formation of platelet plug as well. Platelet plug, let's see, I need a new color. Platelet plug, basically your platelets get activated. So what is that? Activated platelets. Why? Nobody knows what that says. It's supposed to say platelet. Why did they get activated? Because the chemicals produced by the broken blood vessel activated them. Guess who's one of the activators? Thromboxane A2. Oh, that's convenient. Okay, activated platelets get big. They get sticky. They start barfing out more chemicals. Some of those chemicals that they barf out are going to feed into the third process we're going to talk about that happens simultaneously to the other ones. Because they're big and because they're sticky and they're activated by damage, they produce this like sticky plug that sometimes totally solves the problem. Vasoconstrict, cut off blood flow to the area, and then make this sticky blob of blobby stickiness. It's like sticking silly putty in the broken part, and you can totally sometimes plug the hole that way. Apparently, your blood vessels get damaged all the time, and platelet plugs are just chronically produced in order to, like, deal with little tiny damages, like from turbulence or from, no, that wouldn't damage your blood vessels. So awesome. You can make a platelet plug. Those chemicals that activate more platelets, I got to make that clear as well. Those chemicals also activate more platelets, which is like this crazy positive feedback thing. They also initiate clot formation. This is the only part of the process that's about forming a blood clot. All the rest of this is about hemostasis. Let's write that down in my favorite color, hemostasis, because it's about stopping the bleeding. Forming a clot is just one strategy that we can use to stop the bleeding. Now, I'm going to show you a picture really fast. Clot formation is crazy. This is the process of clot formation over here. There's like each one of those chemicals, each one of those little ball things, star, ball, whatever those are, that's all, those are different chemicals. And would you call that a cascade of chemical reactions? Okay, let's call it a cascade of chemical reactions, and then we'll move on. Chemicals from the platelet plug, chemicals from the damage will initiate the clot formation. And you end up with wholly cascade of chemical reactions, and not just one cascade of chemical reactions, but there's actually like multiple cascade routes that ultimately, and this is again the Cliff Notes version, ultimately we're going to end up with a substance called prothrombin activator. Thrombin activator. What do you think it does? You'll never guess. Okay, maybe you will. Yeah, you will. Prothrombin activator is going to activate prothrombin. Here's prothrombin. Prothrombin is going to head into the scene. Prothrombin activator is going to turn it into what do you, go ahead and take a wild guess. What do you think it's going to turn into? It's going to turn into a substance called thrombin. Pro before thrombin. Prothrombin gets activated by prothrombin activator and gets turned into thrombin because it was prothrombin before it was thrombin. And all that crazy is what led to prothrombin activator to do this. Thrombin is not the end game. We have one more process because thrombin is actually going to activate someone else. And my someone else that's going to get activated is fibrinogen. Fibrinogen is going to be activated by my friend thrombin. I ran out of room. Fibrinogen, It's got to be this color. Fibrinogen is acted upon by thrombin, and thrombin does some magic to fibrinogen and turns it into fibrin. And I'm going to make fibrin like a lovely orange. That's kind of yellow. I'm going to make fibrin a lovely yellow because this is actually my end game. Fibrin is the primary molecule found in a blood clot. Fibrin combines with my platelet plug. Fibrin, it's like a crazy fiber. It's like a spider web of madness, and it catches other things and forms that clot thing that you are all familiar with. watch. Okay, well, first of all, actually, I think that this might be the end game. Fibrin is the main substance that you find in your clot, because I just looked at my list of what I want to do next, and I want to talk about things that stimulate clot formation and like how we have a balance, how we don't clot our entire body, because this process, once you initiate clot formation through all these chemicals, it's going to happen fast. And it's going to happen furious. Like it's an aggressive process to form the clot because, dude, if you don't form the clot fast, you're going to bleed out and then not pass on your genes. So those of us who form clots fast are more likely to make babies that will live, especially if you have boy babies that, like, beat the holy living tar out of each other, like, every single moment. Those are my boy babies. That's what they do. And thank goodness for this process. Okay, let's look at some things that promote clotting and some things that prevent it.